Hello, so today we're looking at concavity and points of inflection. Okay, oh dear, that's interesting. That's kind of fun. All right, let's just put that back and get back to business here. Concavity and points of inflection. All right, so for the following functions, find f double prime, points of inflection for the function f, and concavity of f at the given point. All right, let's pick a color to work with. All right, so our function is negative 2x cubed plus 4x squared minus 1, and the given point is x equals 3. All right, so we need to start with the first derivative. Can't get to the second derivative without the first. So let's do that. So negative 6x squared plus 8x. All right, and the second derivative, negative 12x plus 8. All right, so we found that. Excellent. Points of inflection usually occur when the second derivative equals 0. So let's solve for the values of x that give us our second derivative equaling 0. All right, so 0 equals negative 12x plus 8. We're going to solve for x. X equals 8 over 12 or 2 over 3. That's a point of inflection. All right. And then finally, 1, 2, 3, concavity at the given points. To find the concavity, we plug that given point into the second derivative. So f double prime at 3. What do we get? We get 12 times 3 plus 8. Sorry, that's negative 12 times 3 plus 8. This equals negative 36 plus 8. So this is a negative value. So the concavity, therefore, f at x is concave down at x equals 3. So it kind of looks like that. Now let's see if we've answered all our questions. Looks like it. Second derivative, points of inflection, concavity at the given point. Good. All right, well, okay, so we have another one down here. All right, let's pick another color. Be different. All right, so we need to start with the first derivative and then find the second. Okay, let's do this. We're going to take the first derivative. Okay, let's clean this up a little bit. Our 4's cancel out. We're left with x cubed minus 6x squared plus 1. Second derivative equals 3x squared minus 12x. Good. Points of inflection. We set the second derivative equal to 0 and solve for x. Okay, let's see, we can factor out a 3x. So x minus 4. So therefore x equals 0 or x equals 4 are our points of inflection. And finally, we need to find the concavity at the point x equals negative 2. All right, so how do we do that? We plug in f equals negative 2 into our second derivative. We get 3 times negative 2 squared minus 12 times negative 2. All right, let's give ourselves a little bit of space to evaluate that. Okay, 3 times 4 plus 24. All right, so this is clearly a positive number. So therefore, f at x is concave up at x equals negative 2. Good. All right, so I think that brings us to the end of our video today. If you have any questions, give us a shout at info@raisemymarks.com. Give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching.